In this video, we'll have a look at how do we apply geometric sequences to reducing balance depreciation. Now, reducing balance depreciation is when we depreciate the value of the asset based on the updated written down value of the asset each year. So this differs from straight line depreciation, where we're deducting the same amount from the asset each year, which forms an arithmetic sequence. Reducing balance depreciation is going to form a geometric sequence. So we can start off by using our general geometric rule. So Tn is equal to T1 times by r to the power of n minus 1. And we make a few adjustments. So the first adjustment we make is that we're not using a T1 value, but we're using a T0 value. So that's our starting value of the equipment. Our first term in the sequence is going to be the value after 1 year. So because we're using a T0, we don't need the minus 1 at the end, so it just becomes times r to the power of n. Now when we write the formula, you'll often see V for value being used instead of T. So for reducing balance depreciation, the formula that you'll often see and can use is V to the power of n equals V0 times by r to the power of n. Now that r value that we use is going to be 100% minus the depreciation percentage. So you'd be expecting an R value of less than 1 because the value of the equipment is going to be decreasing, and to have a geometric sequence that is decreasing, we need a common ratio of less than 1. So let's have a look at an example of reducing balance depreciation. So in the example, we have office equipment that has been purchased for $17,500. It's being depreciated using a reducing balance rate of 16% per annum. And the first part of the example is asking us to set up a recursion relation to display this information. So before I get into it and write the recursion relation, I want to calculate my common ratio value first, and it's going to be 100% minus my depreciation percent of 16. So that's going to equal to 84%, which I need to convert to a decimal of 0.84. So my common ratio value is going to be 0.84. So that now gives me the information I need to write the recurrence relation. And I'm writing this relation, I'm going to start off with my first term. So my V0 term is going to be 7,500. And then the next value in the sequence is going to equal to the current value times by 0.84. So V0 is equal to 17,500, then Vn plus 1 is equal to Vn times by 0.84. So I can also use the same information to be able to write a rule that allows me to calculate the value after n number of years. So that's going to be Vn is going to equal to 17,500 times by my common ratio of 0.84. And then I'm going to have that to the power of n. Remembering our 17,500 is our 0 term, not our V1 term. So therefore, when we have a V0 term, we use only to the power of n. So that formula is going to find the value of the equipment after n number of periods. So having a look now at part C of the example, and we want to calculate the office equipment value after 4 years. So n is going to equal to 4, and we want to substitute that into our rule. So V4 is equal to 17,500 times by 0.84 to the power of 4, and that is equal to $8,712.75. Although that answers the question because we found the value after 4 years, so that's the future value, it's also important to remember that that is the future value and not the amount of depreciation. If we wanted to calculate the amount of depreciation after 4 years, we would have to go 17,500 and take away that future value of $8,712.75. So that would equal to $8,787.25. So that's the depreciation amount. So that's something to be mindful of. If the questions are asking for future value, you can just use the formula and substitute it in. If it's asking for the depreciation amount, you then need to go ahead and subtract that future value from the original value of the asset. So that's an example of how we can apply reducing balance depreciation to a geometric sequence.